Okay, so this is the range for which the computer will do the computer simulation. Okay, 0 to 250 till 250 seconds. It will try to simulate the thing. Okay, at a step of 10. Okay, so one thing I have forward, I have to give the gravity also, because yesterday only I have taught you. Okay, how many forces we are considering in CFD? Can somebody tell me? Yesterday theory में मैंने बताया था.
Body forces
Pressure
and
force, shear force, and body forces.
Yes. So one are the body forces and another one are the surface forces. Very good. एक था सरफेस फोर्सेस में मैंने क्या किया था, प्रेशर और शियर लिया था. बॉडी फोर्सेस में क्या लेना है मुझे कंपलसरी?
Gravitational force.
यस. सो मुझे ग्रेविटी सिलेक्ट करना पड़ेगा, इसलिए मुझे क्या करना है, ड्रैग फोर्स लेना है. ड्रैग इज नथिंग बट डी सी या फोर्सेस के है, सो ड्रैग फोर्स. ओके, it is a drag na, because see the particles are moving from lower to upper section, so they are getting dragged by whom? Gravity. Okay, तो drag force मुझे ये पूरा मैं सिलेक्ट करूंगा drag. Okay, so drag law is which law? तुम लोग ने FM में पढ़ा था, स्टोक्स लॉ, क्योंकि पार्टिकल का साइज बहुत ही कम है, 1 माइक्रोमीटर. सो स्टोक्स लॉ यूज करोगे तुम. ओके, वेलोसिटी फील्ड किस हिसाब से करना है, डेंसिटी और ये विस्कोसिटी फ्रॉम मटेरियल इटसेल्फ. ओके, टर्बुलेंट फ्लो है क्या, टर्बुलेंट मॉडल यूज करना है क्या? नन, बिकॉज रैंस मॉडल भी होता है, डिस्क्रीट मॉडल भी होता है, कंटिन्यूस मॉडल भी होता है, लेकिन हमारा लैमिनार फ्लो, इसलिए टर्बुलेंट मॉडल. ओके, so then now I have added a time dependent study. Okay, so what I will do, I will compute only particle tracking. Okay, initial values of variable not solved for. Yes. Okay, so now I will do the compute. Let's see whether it is giving some error or. So it is computing. Let's see if it is giving some error or it is running smoothly. Yes. So you can see the flow particles have generated inside the pipe. Okay, so particle trajectory we are having. Okay, now let's see in post processing. Already you have seen the graph तो मैं देखा है, ये काउंटर भी देखा है. अभी मुझे देखना है कि ये पार्टिकल कैसे मूव हो रहा है. Okay, so I will go in export animation, then player. Okay, player, in animation I will take particle trajectory. Okay, player. So I have to make a observation clip or a recording of video whether the particles are really move following the parabolic path or not. For that I will make an animation. In experiment, we make a video by using stereo zoom slow motion camera. In CFD, in post processing, we have an animation. See, have you seen how the nature was? Okay, see, once again I am doing it. So how the particles are approaching towards the outlet? So which path they are up? What is the nature of the movement of the particle from inlet to outlet?
Parabolic path.
Yes, okay. So why? Because I have coupled the dummy particle with my velocity field. And since the velocity field was parabolic in nature, the dummy particle should approach the outlet in parabolic way only. Okay. So that is why, so it is verified. Okay. My theory is verifying with my experiment. And of course, I cannot show you the experiment because we don't have that measurement technique. Earlier, what I used to do, I used to take my students to IIT Bombay, okay, in fluid mechanics lab, where we used to do all those things. But now in pandemic, IIT is not allowing me only to enter from the gate. So there is no chance of taking you. So we can verify our theory with my practice. Okay, so you can increase the number of particle and you can see the nature. You can save such videos. A lot of facilities are there in this software. Okay, now we will see the another way of post processing. Okay, now we will see how the particles they are approaching, means वो कैसे बाहर ये हो रहे हैं. Okay, so for that what we will do, we have to go for this particle 1. ओके, डेटा सेट में पार्टिकल में जाना है, डुप्लीकेट बनाना है एक कॉपी पार्टिकल्स की, उसमें सिलेक्शन करना है, पार्टिकल 2 में जाके बाउंड्री देना है उनकी. ओके, सो बाउंड्री इज दिस, यहाँ पे मुझे सिलेक्शन में देखना है. देन मैं डिराइव वैल्यू में जाऊंगा, देन आई विल गो फॉर ग्लोबल इवैल्यूएशन. द ऑब्जेक्टिव इज नाउ एट व्हाट टाइम द पार्टिकल इज अप्रूव, कौन से टाइम पीरियड में पार्टिकल बाहर आ रहे हैं. ओके, so you can see global evaluation में I have gone, then I will do it for particle 2. Okay, I will select the expression. Okay, यहाँ particle tracking है, particle statistics में जाना है मुझे, total number of particle in selection. And then I have to evaluate. So you will get one table and you can get a plot also. Okay, so see there is a one table, you can see one table is there. I will reduce this. Yes, so you can see the table is there. What time step I have given? 10, 20, 30, 40, 50. Okay, so you can go down. Okay, तो देखा कौन से टाइम पीरियड में पार्टिकल बाहर आना चालू हो रहा है? कैन somebody tell me at which time period?
180 सेकेंड.
Yes, 180 सेकेंड में कितने पार्टिकल्स बाहर आ रहे हैं? 5 पार्टिकल्स बाहर आ रहे हैं. 190 में कितने पार्टिकल्स बाहर आ रहे हैं? 14 बाहर आ रहे हैं. ओके, so you can get it up to 250. So at 250, 46 particles are coming out. So if you will add all those things, okay, all 5 plus 14 plus 23 plus 27, Okay, you can get the exit edge distribution. What is the exit edge distribution? Okay, so that you can get. Also you can plot this. Okay, so here there is one table graph. Okay, so see here, from 0 the particles are inside the pipe till 180 second. At 180 second at outlet they are started coming out. Okay, so it is go on increasing, and after some time period it will be constant. Okay, so for that तुम्हें simulation और run करना पड़ेगा. Let's say I will do it for 400 seconds. 400 seconds, sorry, and whether I can get a constant graph or not, that I have to check. So now again I will do the computation. Practical. So it is simulating. So you are in the progress, you can see how much percentage computation is doing. So basically for running COMSOL smoothly, you should have i7 processor, then at least more than 4 GB RAM. If 8 GB is there, it is well and good. Okay, now let me see the whether what I'm getting is correct. Okay, I'm deleting this. So again, I will go in derived value, global evolution. In global elevation, I will select particle 2. Then in particle tracking, I will do fluid static, particle statics. Total number of particles in selection. Okay, so see, still it is not stable. Okay, it is approaching. Okay, still it is not stable. Okay, so let me run the simulation for more time period. So this is R&D iterations तुम्हें करना पड़ेगा तुम्हारे जो तुम्हारा application होगा उस हिसाब से. So now I am computing it for 600 seconds. Now let's see whether I'm getting this stable thing or not. I'm getting a plateau or not, or still the peak is going above. Let's check. Particle 2, expression, particle tracking, particle statistic, total number of particle in selection, evaluate. Now let's see the table graph. Okay, still see at 600 still it is not getting stable. Okay, so let me increase more time. Let me make it 1000 now. Now again I will go for global evaluation. Global evaluation. Then particle 2. So here see time selection is there. You want only first time period, last, manual or interpolated or all. Okay, there are various options. Evaluate. So this is the advantage of CFD. Just sitting at your own place, you can record the data for as long as much time period you want. Okay, you can record the graph, you can record the videos, okay, without doing any experiment. So this is the advantage of CFD. Okay, so see now at some time period it is becoming constant, but still 100 particle का जो release है अभी वो 90 तक ही पहुंचा है. Okay, 0 to 90. Okay, 100 के लिए और मुझे simulate करना पड़ेगा, but see now it is approaching at least a peak. Okay, so you may do it for 1500 seconds or 2000 seconds and you can see how the graph will be. Okay, so I hope the particle tracking module, of course it is not inbuilt in your syllables, but these are all real life. See, particle tracking module we use